Students, hope you are all doing well. We are back again with another video lesson. Today's lesson we are going to talk about the sound intensity and resonance. In this section we have two topics, sound intensity and resonance. In section 2, chapter 4. What is the sound intensity or wave intensity, or the definition of sound intensity? The rate at which energy flows through a unit area perpendicular to the direction of the wave motion. Okay, what is intensity? Intensity is the amount of the energy per unit of time. Okay, so we can represent mathematically, or you can express mathematically, the sound intensity. I is equal to what? The time rate of energy per unit of area. What is intensity of sound? Is the rate or time rate of the energy flows through a unit area or per unit of area perpendicular to the direction of the wave motion. Or another definition of sound intensity is a power per unit area, and it is SI unit is watt per meter square. So as you studied in grade 11, the time rate of energy is equal to power. What is power? The time rate of energy, power of area. So we can express the equation of intensity as a power per unit of area. So as we studied in section 1, the sound propagates in all dimensions as a spherical wave, which is equal to area of spherical is equal to 4 pi r square. Which equation is correct about the intensity of sound? All three equations are correct. We can express the equation of sound intensity, time rate of energy per unit of area, or power per unit of area, or power over 4 pi r squared. Area of sphere, because the sound propagates in all directions, in all three dimensions, such as a sphere. So the area of the sphere, according math basic, is equal to 4 pi r squared. Right? According to this equation, when we say I is equal to power over 4 pi r squared, guys, look, what is relation between intensity and power at constant distance? At constant distance, the relation between intensity and power is directly proportional. Okay, so what about the distance? Intensity is inversely proportional to the square distance at constant power. So this is very important. According this equation, intensity of sound is equal to 4 pi over 4 pi, power over 4 pi square, 4 pi r square. According this equation, what is relation between intensity of sound and power is directly proportional. But you have to say at constant distance, or at a given distance. Okay? At a given distance, intensity is directly proportional to the amount of power. So what about intensity with distance? Intensity is inversely proportional to the square distance at constant power. Or at a given power, intensity is inversely related with the square distance. Okay? So this is the equation of sound intensity. I is the sound intensity measured in what? Power measured in watt. What is the SI unit of power? Watt. What about distance? Meter. Square of distance? Meter square. Sound intensity measured in what? Watt per meter square. Watt per meter square. Or another equation, guys, according to this equation, power is equal to the time rate of energy per unit of area. Energy measured in what? Joule. Area, meter squared. Time, second. Can we represent the unit of the intensity as a joule over meter square second? Yes. Okay? So, intensity, the equivalent unit of intensity, watt per meter square second, sorry, watt per meter square, watt per meter square, or you can say joule over meter square second. Okay, and also you can convert joule to what? Newton meter over meter square second. Meter with meter cancel. Newton over meter second. Sorry. Meter second. This is the equivalent unit of intensity of sound. P is power measured in watt. R is the distance from the source measured in meter. Area measured in meter square. Time rate of energy, delta U over delta T, is the time rate of flow energy measured in watt. So the intensity of sound is related with the loudness. Intensity of sound is related with what? With the loudness. A higher intensity, it means the louder sound. More intensity, more loudness. The relation between the intensity of sound and the loudness is directly proportional. When does the sound's loudness becomes more? If its intensity gets higher. What is the sound power? Is the time rate. What is power? Time rate of flow of energy. The time rate of flow energy of sound and measured it in watt. At constant distance from source, I is directly proportional to the power. What does the sound intensity depend on? The sound intensity depend on what? According to this equation, sound intensity depends on the power of the source, the time rate of the energy of the source, and the area of the sound wave. With the power directly proportional, but with the area is inversely proportional. Power emitted by the source and the square distance, or you can say the area of the sound wave, because area in a spherical wave is equal to 4 pi r square, depend on power and the square distance from the source. We have some notes about the intensity of sound. In a spherical wave, because the sound propagated in a spherical wave, energy propagates equally in all directions. In this case, the power emitted by the source is distributed over spherical surface. So the area of spherical surface is equal to 4 pi r square. Instead of this area, can you write 4 pi r square? Yes, you can do it. So assuming that there is no absorption in the medium, if there is no absorption of the medium, you can calculate the intensity of the sound. Guys, as I told you, the relation between the square distance intensity is inversely related. In the case when two intensities are given, or when two distances are given in the equation, in the question, sorry, how can you determine the second intensity or the second distance? By using this equation. I1 over I2 is equal to, because the relation between intensity and the distance is inversely related, so we have to write down R2, not R1, guys, be careful. For any inversely relation between two physical quantities, if you write down 1 over 2 in this side, for the second side, in the other side, you have to write down 2 over 1, because they are inversely related. R2 square over R1 square, over R1 square. According to this equation, you can calculate the increasing or decreasing, or by which factor the intensity of the sound increases if the distance becomes double or becomes triple or becomes half, or when two distances or two intensities are given, you can use this relation. Okay? The units of the sound intensity, as I prove it for you, this is the main unit of intensity, watt per meter square, and also you can express the unit of sound intensity, joule over meter square second. So 1 over second is equal to hertz. You can write down joule hertz over meter square. Okay, and also you can write down instead of joule, Newton meter. Okay, hertz is equal to 1 over second, Newton meter over second meter square. Meter with meter cancel. What is remain? Newton over second meter or meter second. And Newton also is equal to kilogram meter per second square. meter with meter cancel, second with second squared gonna be second cube, kilogram over second cube also is the equivalent unit of intensity. If they bring in the Wizari exam, which of the following is the equivalent unit of intensity? This one is correct, also this one is correct, okay? Be careful. The relationship between intensity and distance is inversely proportional. The intensity of sound wave decreases as the distance from the source increases. The intensity of the sound wave decreases as the distance from the source increases at constant power. This occurs because the same amount of energy is spread over a large area. The source's power does not change with the distance from the source. The source's power does not change. Only the intensity of the sound changes. Okay? What does the intensity of sound in a given point depend on? In a given point, the intensity of sound depending on many factors. The first one, the square distance from the point to the sound source and inversely proportional. The intensity of sound in a given point depends on the square distance. As the distance gets more, the intensity of sound becomes small. The square amplitude, directly proportional. Why? Because if you remember, we studied this, energy is equal to radical of A. Okay? So what is the relation between, the relation between energy and amplitude is directly proportional. E is equal to, directly proportional to the square, not radical, sorry. Energy is directly proportional to the square of amplitude. When amplitude gets more, what happened to the energy? The energy also increases, guys. When amplitude gets more, what happened to the energy? Energy also gets more. So when the energy gets more, what happened to the sound intensity? Sound intensity also becomes more and more. Why? Because energy with the intensity is directly proportional, and energy with the amplitude also directly proportional. So by increasing area, what happened to the sound intensity? Sound intensity also increases. Okay? The area between the sound source and the observer are inversely proportional. When the area increases from the sound source, because the power is constant, so this power is distributed over the large area, so that is why its intensity decreases. The area of vibrated source, guys, there is a difference between 3 and 4. In number 3, this is the area between sound source and the point from the sound source. When this area gets more, the intensity becomes small. But the area of vibrated source is directly proportional to the sound intensity. When the vibrated source increases, what happened to the sound intensity? The sound intensity gets more. The vibrated source is directly proportional to the intensity of the sound. As this vibrated source increases, the intensity of sound also increases. But the area between the sound source and the observer is inversely. More area has less intensity. Guys, doubling the distance from the source will have greater effect on the intensity than doubling power. Why? Because according to this equation, power is equal to 4 pi r squared. Doubling distance has more effective than doubling power, because distance is square, but power is pure. It has no power, okay? So, because intensity is directly proportional to the power without square, but the relation between distance and intensity, there is a square of the distance, so that is why the radius or distance from the source has more effective than the power because of this square. If they bring in the exam, sound intensity, as we know, depends on power and distance from the source. But which of the power or distance has more effective to change the intensity of sound? The distance from the source. Why? Because according to the equation of intensity of sound, the distance from the source is square, but the power is absolute power, pure power. There is no square on the power. Like for example, if both power and distance were doubled. For example, if P1 is equal to twice of P2, R1 twice of R2, what happens to the intensity of sound, the intensity becomes half. Why? Because the distance has more effective than the power. Why? Because I2 is equal to what? I1 is equal to P1 over 4 pi R1 square. I1 becomes what? The question is, I1 changes by which factor of I2? If I double both power and distance from the source. P1 is equal to what? 2P2. Sorry. You have to compare by a fraction. I1 is equal to P1 over 4 pi R1 square. I2, P2, 4 pi R2 square. P1 is equal to 2P2. P1 is equal to what? 2P2 over 4 pi R1 is equal to what? 2 R2 square over P2 over 4 pi R2 square. 4 pi with 4 pi cancel. P2 with P2 cancel. What is remain? 2 over 2 squared 4 R2 square over 1 over R2 square. R2 with R2 cancel. What is remain? 2 over 4 over 1 over 1. Okay, so it becomes 2 over 4 or becomes half. So I2 is gonna be half of I1. Okay, so we doubled both power and distance, but because the distance from the source has more effective because of this square, so that is why the intensity of the first time becomes half of the intensity of the second time. If both power and distance were doubled, then the intensity will drop by which factor? By factor of half. By which factor? By factor of half. So you can do it by, if we both power and distance were halved, by which factor is the intensity changes? By factor of double. So this is homework, you can do it by yourself. What happens to the sound intensity when the sound wave moves away from the source? Moves away. What do you mean by moves away? It means that R gets more, intensity becomes less. The sound intensity decreases because the amount of sound energy is spread over a large area. So as the distance gets more from the source, this is source, the intensity becomes less and less. For the first time, we have I1. The second time, I1 over 4 decreases by factor 4, decreases by factor 9 here. We have some questions about the relation between intensity and the distance from the source. If the distance from point source of sound is tripled, distance from point source, if source of sound is what? Tripled. It means that R2 is equal to 3R1, tripled. The distance from point source of the sound is tripled. By what factor does the sound intensity change it? I2 is equal to how many times I1? Guys, look. If you have 2I or 2R, as I told you, you have to use this relation. I1 over I2 is equal to R2 square over R1 square. I1 over I2 is unknown. R2 is equal to what, guys? 3R1. 3R1 square over R1 square. Bring down I1 over I2. 3 square, 9. R1 square, R1 square over R1 square. R1 square with R1 square cancel. What is remain? I1 over I2, 9 over 1. Cross product. If you cross product, 1 times I1, I1. 9 times I2, 9 I2. By which factor does the intensity of the sound change it? By factor of 9. because the distance, the sound, the tripled, sorry, I2, sorry, I2. We have to find I2, guys. Look, I2 is equal to how many factors of I1? I1 over I2 is equal to 9 over 1. I2 times 9, 9 I2. 1 times I1, I1. I2 is equal to what? Is equal to 1 over 9 I1. I2 changes or change it by factor or decrease it by 1 over 9 or decrease it by factor of 9 or change it by factor 1 over 9. Which one is correct? 1 over 9 because the distance gets more or triple. So another way to solving this question in a fast way you can calculate I is inversely proportional to the distance. In this question the distance is tripled. Increases by factor 3. Triple, it means that 3 square. I is equal to 1 over what? 1 over 9. I2 is equal to 1 over 9 of I1. Also, you can use this way to find this relation. Another question. By what factor the distance from the sound source must be changed? Okay. R2 is equal to how many times R1? By what factor the distance from the sound source must be changed in order to the intensity of sound intensity becomes what? 4 times. Sound intensity becomes what? 4 times. In this case, write down the equation because if 2 distance or 2 intensities are unknown in the question, I1 over I2, guys, I1 over I2 is equal to R2 square over R1 square. I1 over I2 is equal to what? Instead of I2, write down what? 4I1 is equal to R2 square, R1 square. Okay? I1 with I1 cancel. What is remain? 1 over 4 square, R1 square. Cross product to find R2. R2 square times 4 is equal to R1 square. R2 square is equal to R1 square over 4. Take the radical to remove this square. R2 is equal to what? R1 square over 4. R2 is equal to radical of R1 is R1, radical of 2, it becomes R1 over 4, or R2 is equal to 1 over 4 of R1. The second distance must be changed by factor 1 over 4 or decreases by factor 1 over 4. Okay? But radical 4 is 2. Sorry. Radical 4, this is 4. Radical 4 is 2, not 4. Sorry. 2. Radical 4 is what? 2. R2 changes by factor 1 over 2. By factor what? 1 over 2. Why? Because radical 4 is 2, not 4. We have to take out the 4 under the radical. So radical 4 is equal to 2. Another question, guys. If the sound intensity of a given point changes by factor 1.9. What is this? This is the intensity of the sound. I inversely proportional to the R. So this relation can be used when R is given. When R is given to find intensity. But another relation, R is equal to what? 1 over radical of I. This is the same thing, guys. I inversely proportional to the square of distance, R also inversely proportional to the square root of intensity. This relation can be used when I is given. Okay? If the sound intensity changes by factor 1 over 9, what is this? This is I. I was given 1 over 9. By which factor does the distance from the source changes, must be changed? Because the distance, the intensity is given are inversely proportional to the radical I. Radical 1 over 9. It's gonna be flipped because we have two fractions, 1 over radical 9, okay? R2 becomes 3 times of R1 because intensity becomes less, so R must be increased by factor 3. R2 is equal to 3R1. If the question asks us to find the ratio, maybe they will bring in the ratio. The questions can be asked for a ratio. Whenever it asks for ratio, solve it as follows. What is the ratio of the sound intensity from distance 3 meter to the sound intensity of 1 meter? What is R1? 3 meter. R2, 1 meter. What happened to the R? Less, becomes less, gets lower. When distance gets lower, what happened to the intensity? Intensity more. How can we solve this ratio? Guys, we have to find the ratio I1 over I2. Okay? Is equal to what? R1 square over R2 square. The ratio of I1 over I2 is equal to what? R1, 3 meter square. R2 square. I1 over I2 is equal to what? 9 over, sorry, I made a mistake. Not like that, good. I1 over I2, as I told you, the relation between intensity and R is inversely R2 square over R1 square, guys. I1 over I2, R2, 1 square, R1, 3 square, I1 over I2, it's gonna be 1 over 9. So the ratio of I1 of I2 is 1 over 9. Another question about the ratio. What is the ratio of the sound intensity from distance 1 meter to the sound intensity from of 3 meter? R1, 1 meter. R2, 3 meter. R gets more, intensity must be less. Okay? The intensity of the sound must be less. Okay? So because from 1 meter to the 3 meter, the distance increases, so the sound intensity is less. What is the ratio of the sound intensity from a distance 1 meter to the sound intensity of 3 meter? I1 over I2 is unknown. I1 over I2 is equal to R2 square over R1 square. I1 over I2, do we have R2? Yes, 3 square. R1, 1 square. I2 over I1, I1 over I2 is equal to 9 over 1. So you can cross product I1 is equal to 9 times of I2. Why? And I2 is equal to 1 over 9 of I1. Why? Because R gets more, intensity must be less for the second time because the distance changes from 1 meter to 3 meter. R gets more, so I2 is equal to 1 over 9 I1. But I1 over I2, it's gonna be 9 over 1 or 9. Okay? So this is 9 or 9 over 1. So this relation is very important between the intensity and the distance from the source, which is inversely related with the square distance. When distance gets more, the intensity or the loudness of the sound gets less because they are inversely related. Why is the intensity of an echo less than that of the original sound? The intensity of the echo sound is always less than the intensity of the original sound because in the echo, What do I mean by echo? It means that when the sound emitted by the source and reflected by the wall or any other object, okay, when the sound reflected, the reflected sound gonna be echo. So the reflected sound or echo has traveled more distance, moving forth and back. More distance, it means that less intensity. Why? Because intensity is inversely proportional to the distance from the source. For the first time, original sound, the distance of the sound traveled, for example, 2 meters. And then reflected, it means that echo traveled also by 2 meters. 2 meters with 2 meters, 4 meters. It means that distance becomes more, intensity becomes less. Because intensity decreases with distance, and the sound has traveled from the source or reflecting to the reflecting surface and back. Okay. Another topic, guys. Intensity and frequency determine which sounds are audible. If you remember in chapter 1, we studied the audible sound. We had 3 different types of sound: infrasonic sound, ultrasound, and audible sound. In the audible sound, the range of frequency was between 20 hertz to 20,000 hertz. But guys, be careful. To determine which sound is audible sound, we need what? Both frequency and intensity. Okay? For example, if they bring in the exam, which of the following determines which sounds are audible? Frequency, intensity, both of them are correct. Not only frequency determines which sound is audible sound, but also intensity has a factor to determine which sounds are audible sound. The range of human hearing depends on both the frequency and the intensity of sound wave. What does the range of human hearing depend on? It depends on the frequency of the sound and the intensity of the sound wave. Sounds in the middle of the spectrum, in the middle of the spectrum of frequencies can be heard more easily than at lower intensity, than those at lower and higher frequency. Now I'm going to explain why the sounds at the middle of the spectrum can be heard more easily than the lower and higher frequency. The frequency of sound wave heard by the average human ranges from 20 hertz to 20,000 hertz. What is the range of the audibility of the frequency? From 20 hertz to 20,000 hertz. This is the range of the frequency. So intensity is also has a factor in determining which sound waves are audible. So figure below, this figure shows how the range of audibility of the average human ear depends on both frequency and the intensity of the sound wave. Sound at a lower frequency, those below 50 hertz, lower frequency, or higher frequency, those above 12,000 hertz, must be relatively intense or must have more intensity to be heard, whereas sounds in the middle of the spectrum are audible at lower intensity. Which frequencies require more intensity to be heard? Lower frequency less than 50 hertz or more frequency more than 12,000 hertz? Both of them. Guys, be careful. Once again, listen carefully. Which frequencies require more intensity to be heard, the sound to be heard? Low frequency or high frequency? Both of them. Both low frequency and higher frequency, they require more intensity to be heard. So that is why the middle of the spectrum can be heard more easily than the lower frequency or higher frequency, because at the middle of the spectrum the sound requires a little intensity to be heard. Look, what does the human hearing depend on? Frequency of the sound wave and intensity, both factor, frequency and intensity. Look at this spectrum, guys. Look at this spectrum, it's very important. Okay, what is this? This is the range of audibility of an average human ear. We have two curves, intensity and frequency. Guys, inside the spectrum, we can hear the sound. Inside this line, we can hear the sound. But out away from this line, the sound is not here. There is no sound here. There is no sound here, guys. Out of this range, no sound can be heard. Okay? For example, look. What is the amount of frequency here? Frequency is 50 hertz here. When frequency is 50 hertz and at this point, can we hear this sound? No. We cannot hear this sound, guys. We cannot hear this sound. Why? Because this point is not located inside this range. But here, inside this range, the sound can be heard. Okay? So when does 50 hertz can be heard? When does we can hear this sound with the frequency of 50 hertz if the sound source has intensity about 10 power negative 6 here. Okay? But when the intensity is equal to 10 power negative 10 at this point, can we hear this sound? This sound is not audible. The sound out away from this curve is not audible sound. So, less than 50 hertz, like 30 hertz, guys. When frequency is 30 hertz, can we hear with 10 power negative 10 intensity? No. We have to increase the intensity. When it goes up, what happened to the intensity? Intensity becomes more. Guys, increase the intensity until the intensity reaches what? 10 power negative 4. When the intensity is equal to 10 power negative 4 and frequency is less than 50 hertz, can we say this sound is audible? Yes. So generally, the low frequencies less than 50 hertz require what? Require more intensity, about 10 power negative 2 or 10 power 0 or 10 power negative 4. The frequencies below 50 hertz, with the small amount of intensity, this sound cannot be audible sound. We cannot hear this sound. Our ears cannot detect this sound. Guys, the same thing is right for the high frequency. Look at the high frequency. High frequency more than 12,000 hertz. Assume that this is 12,000 hertz. In the 12,000 hertz, when does the sound can be heard in 12,000 hertz? If the intensity is equal to what? If the intensity is equal to 10 power negative 12. At 10 power negative 6, can we hear this sound with the 12,000 hertz? No. So, for 12,000 hertz or more than 10,000 hertz, when does this frequency can be heard, or when does this sound can be audible sound? If its intensity is enough more. If we have more intensity. So, generally, can we say the lower frequency, less than 50 hertz, and higher frequency, more than 12,000 hertz, requires more intensity? Yes. Requires more intensity. So, but the middle of the spectrum, at the middle of the spectrum, this frequency between 200 hertz until 5,000 hertz, this middle of the spectrum, they require low intensity to be audible sound. Okay? The frequencies between 200 or 5,000 hertz requires a less or a little intensity to be heard by the human ears. Guys, this zone or this position is called threshold of pain. Threshold of pain at intensity 10 power 0. And this position, okay, the lower of the spectrum, this position is called what? Threshold of hearing. Threshold of pain has more intensity. That is why we call it threshold of pain. But threshold of hearing has the minimum intensity or has the least intensity. Threshold of hearing, threshold of pain. What is threshold of hearing? The softest sound. Why softest sound? Because its intensity is too less. Threshold of hearing, the softest sounds that can be heard by the average human ear occur at a frequency about 1000 hertz and intensity 1 times 10 power negative 12 watt per meter square. Threshold of pain, the loudest sound, that is why we call it threshold of pain. The loudest sound that human ear can tolerate or can detect have an intensity about 1 watt per meter square. Guys, that's all for today. Inshallah, next lesson we will continue explaining the intensity of sound, and we're going to solve the questions that related with the intensity of the sound wave. Thank you for listening and keep up your best doing.